Alright, so we are going to graph the cosecant and secant functions. And I'll say if you're comfortable with graphing sine and cosine functions, you're going to be just fine graphing cosecant and secant, because we're going to set up a way to do that by using sine and cosine. So if I have y equals cosecant of x, so that's going to be the parent graph. And we remember that cosecant of x is a reciprocal of sine. So cosecant of x is the same thing as 1 over sine of x. So if I set up my values here and look at my parent sine function, right, I've got x and then I've got the sine of x. All right, so we're going to use our values 0, 90, 180, 270, 360. So there are my 5 points. And I know that the parent graph for sine is 0, 1, 0, negative 1, 0. All right, so what I'm doing here for cosecant, or 1 over sine of x, right, I'm taking the reciprocal of these values. So the reciprocal of 0, if I flip that, if I take 0 from the numerator to the denominator, that's going to be undefined. If I take the reciprocal of 1, that stays 1. And then I've got undefined value again. Negative 1 stays negative 1. The reciprocal of negative 1 is negative 1. And then I'm back to undefined. All right, so let's look at the graph of this. So I'm going to draw this graph. .360. I'm actually going to draw the graph of sine. First. All right, so we know that we start at 0, go up to 1, back to 0, down to negative 1, then back to 0. All right, so this is my sine graph. All right, if we look at the reciprocal of that parent graph, all right, what I'm talking about here is my zeros become undefined. So those are asymptotes, and you've talked about asymptotes before in a pre-calculus class or an algebra 2 class. All right, this is where the graph does not cross. The graph cannot cross an asymptote. All right, so anything that's undefined is not in the domain, and it creates a vertical asymptote. All right, now I also have a value at 91. All right, so at this point, what I'm trying to figure out is what's going on to the right and the left of that asymptote. What's happening as I approach that asymptote from the right or to the left? Well, if you think about it, from 0 to 90 degrees, that would be in quadrant 1. Sine is positive, which means cosecant is positive as well, which means it's going to positive infinity. All right, if I think about it that same way, from 90 to 180, that's quadrant 2. Remember, sine is positive in quadrant 2, which means cosecant is positive in quadrant 2, so I'm going to positive infinity that way as well. Okay, so then I have another asymptote, and then down here, I've got a value at 270, negative 1. Well, in that third quadrant, from 180 to 270, that's quadrant 3. It's going to be negative, because sine is negative, which means cosecant is negative. And so it is in the fourth quadrant as well. All right, so this white part, not the yellow part, that was my sine graph, but this white part is my cosecant graph. All right, let's do the same thing for secant. All right, so I've got y equals secant of x, which is the same thing as 1 over the cosine of x. All right, when I get my 5 points here, I've got 0, 90, 180, 270, back to 360, and for cosine, that's 1, 0, negative 1, 0, back to 1. All right, so 1 over cosine, the reciprocal of that, 1 stays 1, 0 goes to undefined. -1 stays -1, undefined, and then I'm back to +1. Alright, so let's look at the graph of this. I'm actually going to do the same thing here. I'm going to graph my cosine function in yellow so you can see it. Alright, so we start at, go to yellow. Ah, yellow. So we start at 0, 1, then we go to 0, down to -1, back to 0, and then we starting all over again with the periodic function. Alright, so this is my cosine graph. Alright, but we're graphing secant graph. So my asymptotes, remember my zeros become asymptotes. So that's going to be an asymptote. That's going to be an asymptote. They're undefined. So I'm just looking at what's going on to the right and to the left of that asymptote. In quadrant 1, cosine's positive. So it's going to infinity. Quadrant 2, cosine's negative. Quadrant 3, cosine's negative. So it's approaching negative infinity on both sides of those asymptotes, and then the fourth quadrant is positive again. So that is the graph of secant of x, just the white part. Alright, so in general, this is going to be our strategy. Alright, but even before I talk about the strategy, let's talk about, I do want to point out something before I go on to our strategy. So looking at both of these graphs, if any graph we've done before, we talk about the amplitude, the period, phase shift, vertical shift. Alright, so if you look at cosecant and secant, notice that they go on and on to infinity, or on and on to negative infinity, which means there is no amplitude. Alright, that's going to be important, because even though we're going to use cosine and sine to graph these functions, it's important to remember that they're not going to have an amplitude. Cosine and sine do, but cosecant and secant will not have an amplitude, so there is no amplitude. Alright, the period is going to be the same. And what our strategy here is we're going to graph let me say using the sine function and the cosine function. Alright, and then we're going to draw our asymptotes. Where our zeros are. Okay. We want to remember that there's going to be no amplitude, so we want to go back and do that. What else? Alright, and then we're just going to use the behavior to the right or left of the asymptotes. To finish our graph. Alright, and you'll begin to see a pattern. In other words, what I'm saying here is we're going to graph these just like it was sine x or cosine x, depending on if it's cosecant or secant. Then, after we've gotten our graph, the sine or cosine graph, we're going to draw our asymptotes where the zeros are on sine and cosine, because those zeros are going to become asymptotes. And then I'm going to use the behavior to the right or the left of those asymptotes to finish our graph. Alright, that means that at these peak, like at the peak of the maximum of my sine or cosine graph, I'm going to be going to positive infinity, and at the minimum of these graphs, let me do that, the minimum, like here is a minimum, I'm going to be going to negative infinity. All right, so you'll begin to see that pattern. So let's do an example here. All right, so let's use the example y equals 3 times the cosecant of x plus pi over 2. All right, so this is what I'm talking about. I'm going to graph this just like it were y equals 3 times the sine of x plus pi over 2. So I'm going to go through this whole process. I'm going to pick my 5 points, I'm going to graph it, and then I'll show you how we use the asymptotes to finish our graph. All right, so this particular graph, if I were graphing it like sine, I would say my amplitude is 3, right? But remember, and this is one thing that you can't be careless with since we're using this method to graph these functions, there is no amplitude. Even though I'm using the sine function to graph it, it's the cosecant function, so there's not going to be any amplitude. The period of sine is 360, the parent graph. That means the cosecant period is going to be the same thing. Remember, to find the period, I take 360 and divide it by the b value. In this case, my b value is 1, so the period here is going to be 360 degrees. So this is going to repeat itself every 360 degrees. The phase shift, right, it's my c value. In this case, it's negative 90 degrees, right? That's in radians, but I can convert it to degrees, and then there is no vertical shift. All right, so I'm graphing this. If I have a phase shift, that's where I start. So I'm starting at negative 90 degrees. To get my next point, I take 360 divided by 4, which is 90 degrees. So my next point is going to be negative 90 plus 90, which is 0, plus 90, which is 90, plus 90, which is 180, plus 90, which is 270. So there are my 5 points. In this case, I've got an a value of 3, which means instead of 0, 1, 0, negative 1, 0, I'm multiplying that by 3. My zeros stay the same, because anything times 0 is 0. My 1 becomes 3, because 1 times 3 is 3. And then my negative 1 becomes negative 3, because negative 1 times 3 is 3. All right, so this is x, and this is 3 times the sine of x plus 90. Okay, so I've got that. That's what this graph is going to look like. So I'm going to draw that out. So I've got negative 90 because I'm shifting to the left 90 degrees. I've got 0, then I've got 90, then I've got 180, 270. This thing is going up to 3 and down to negative 3. So I've got 0, 3, 0, negative 3, 0. Okay, this is my sine graph. That's what I'm using to get my cosecant graph. All right, so my strategy here is I have the sine graph, the sine function graph. So I'm thinking reciprocal of that. So my cosecant graph, my zeros are going to become asymptotes. So those become my asymptotes. Right, and then I'm looking to see what's going on to the right and to the left of those asymptotes. If I've got a maximum, those are going to positive infinity. If I've got a minimum, those are going to negative infinity, right? cosecant function. This white part is the cosecant function. I used sine to graph it. It's real easy. If you can graph sine functions with the transformation, do it. Your zeros become asymptotes, and then you just finish your graph by looking at the behavior toward the asymptotes.